So review for exam 3, for example, a question like this may show up. They will give you an angle like 53 degrees, and they will ask you to figure out two coterminal angles, one positive, one negative, right? Yeah, so how we do that? Well, remember in trigonometry, we have this nice fact, which says that if we add or subtract 360 degrees, a full revolution, right? To an angle, basically, we are not changing the angle trigonometrically speaking, right? Because we are kind of going back to where we started, right? So whenever you have an angle in trigonometry, feel free to add 360 degrees or to subtract 360 degrees, and the angle that you get will be coterminal to the given angle, right? So adding here, I'm gonna get, let's do it with a calculator, 53 plus 53 plus 360 is 413. So believe it or not, guys, this 413 degrees in trigonometry, exactly the same as 15 degrees, trigonometrically speaking, right? They have the same trigonometric functions that are called coterminal angles. So this will take care of the positive coterminal angle. Now, in addition to this, I want a negative coterminal angle. So no problem, instead of adding, it's clear that we must subtract now, right? Let's subtract. So 53 minus 60, negative 307. Negative 307 degrees is a negative coterminal angle, which tells me that the answer should be this, right? Good. Now, as a practice, can you try to number 2? Do this, guys. Yeah. Generate a positive coterminal angle, a negative coterminal angle. If you don't see the angle well, it's negative 41 degrees now. I see students readily posting answers. Very good, Mamadou. Very good. Excellent. Excellent. Mamadou, if you don't mind, what did you do to get the positive coterminal angle?
Oh, I just add 360.
Excellent, excellent, right?
Yeah.
And as a result, you should get this 319, right? Excellent. Yeah. And to get the negative angle, what do you do?
Minus 360.
Minus 360, right? Yeah, it's kind of, I wouldn't say obvious, but it's kind of clear, right? Because if you add, you're going to keep getting positive coterminal angle without the negative one. So this is excellent, excellent. Great. Now, they are asking you to do the same now, but with this angle in radians. But that shouldn't be a problem because, again, you should add now 360, but we have to do it in radians. Now, in radians, 360 degrees, a full revolution is 2 pi radians, right? So add 2 pi, hint here, to get the positive coterminal angle, and to get the negative coterminal angle, subtract 2 pi, right? Sometimes the students tell me when I do this, Professor, what if I convert this to degrees, get the job done, and then put it back in radians? That also works, guys. That also works. That's another option if you prefer, right? But I'm going to use this approach. Yeah, so. Okay, so if I use this approach, just for the sake of variety, right, I must write one below here. I see students figure this out. Number 3. Mamadou. Good, good, very good, excellent. Yeah, you got it. Right? Yeah, so basically, if I put 1 below 2, it's the same as 2. This allows me to multiply numerator and denominator by the LCD here, which is 6, right? 6 times 6 times 6. And as a result, I will get pi over 6 plus 6 times 2 is 12 pi. 6 times 1 is 6, right? And now that they both have the same denominator 6, I can add pi plus 12 pi. And believe it or not, guys, 1 pi plus 12 pi is 13 pi, right? over 6. This guy is a positive coterminal angle of pi over 6. Great. Now for the subtraction, similarly, right? If you work this out by placing here 1 below 2, and you multiply by 6, numerator and denominator, to get on the denominator the LCD, this will be 12 pi over 6. And this is going to be pi minus 12 pi over 6. But now here there is an invisible one, right? That was present here too, invisible one. 1 minus 12. 1 minus 12 is just minus 11, right? Minus 11. Minus 11 there. And pi, don't forget pi, right? Divided by 6, right? And this is telling me that the answer now, this guy, right? So be prepared, right? This question could be in radians or in degrees, be prepared. Okay, next question 4. It says convert the angle from degree measure to radian measure, round to the nearest 100 of a radian when appropriate. All right, but look, when they are asking you to convert 90 degrees to radians, you can see that the answers are all in terms of pi in exact form. So we should just do this in exact form. Remember, to convert from degrees to radians, you multiply your angle in degrees by this factor, right? 180 degrees, same as pi radians, right? Pi radians. Why you write this 180 degrees on the bottom, Professor? Well, it's because I want to eliminate these degrees and I want to output radians, right? But this will be just 90 pi over 180. Radians, I don't need to write radians, it's an agreement, right? And now simplifying this, divided by 90 both, you get this to be pi over 2, right? Which is something that we know at this point, pi over 2 radians is 90 degrees, right? Great.
Now that we know what we know, can we use the unit circle for these?
Really? Yeah, thank you. Yes, absolutely. So use all your tools, guys. Look, Regine is saying, right, in the unit circle, it's pointed out, it's shown that 90 degrees is the same as pi over 2, right? Can I pick up on that? Sure, absolutely. Yes, yeah, that's it, right? Pi over 2. Excellent. Yeah, use all your tools, guys. Have this sheet, the unit circle sheet printed out handy there, right? Yeah, good. That's it. Now, minus 60 degrees, right? Minus 60 degrees now is a negative angle. So if you want to use the following the method that is follow, multiply this by pi radians divided by 180 degrees, right? This cancels. And this is 60 over 180. Don't forget the sign, negative. And simplifying, this will be negative pi over 16 to 183, right? And if you can get it from the unit circle, in the unit circle, I think it's all positive, the angles, right? But if you notice, this can be done there too, right? Pi over 3 is this 60 degrees. Great. Now they want you to do the same with 810 degrees. This is not in the unit circle, right? It's a general angle, but the method that you follow should be the same, right? 180 degrees here, pi radians on the top. So eliminating the degrees, you get 810 over 180 pi. I don't have to write radians anymore. Now simplify, right? Simplify. For example, divide by 10 both, right? So 81 over 18 pi. But still I can divide by a common divisor 9 here. So this will be 9 pi over 9 into 18, 2, right? That's it. You see, guys? 6. Great. So next, let's continue. What about doing this in reverse? What if they give you the angle in radians, 9 pi over 2, and they want this angle in degrees, right? Well, you do kind of the opposite, right? You kind of do this in reverse. I'm gonna do it in reverse, right? pi radians on the bottom. Now 180 on the top degrees, because we're gonna output degrees, we wanna eliminate radians, right? So this cancels, pi cancels. Final result 9 times 180 over 2. And this is something that you can get in your calculator, right? 9 times 80, 180. The 80 over 2 is just 810 degrees, right? And it's something that we did before in reverse, right? Look, we did this in reverse, right? This confirms that, right? So this is good. Could be any angle, right? It happened to be just that. So this guy, great. Moving on. They want you to convert this to degrees, right? This radians to degrees, multiplied by pi radians on the bottom, 180 degrees on the top. Radians cancel with radians, pi cancels with pi. You end up with minus 180 over 3, right? But this guy is just 3 into 18 is 6, followed by 0, 60 degrees, right? Or you can look at the unit circle also and check what goes with pi over 3, but don't forget about the sign, right? The sign should be attached, right? Yeah. Yeah, in the unit circle, yeah, good that you wrote this out. Look, pi over 3, where is that? Pi over 3 goes with 60, but remember it's minus pi over 3, so it's gotta be minus 60 degrees, right? Yeah, you can use the unit circle in some cases, right? If you can. Now this one is general, 9 pi over 4 converted to degrees multiplied by pi radians, which is equivalent to 180 degrees, right? We're writing this on the bottom because we want to eliminate radians and output degrees, right? So this is this. So use your calculator, times 180 over 4, and that's it, right? 405. 405 degrees, right? This guy. That was for number 9. Great. Then we go into this business of computing complementary angle and supplementary angle, right? For complementary angle, remember the angles must add up 90 degrees, and we have a formula to deal with complementary angle. What is that formula? It's just this, right? 90 degrees minus given angle, right? Given angle. That gets you a complementary angle. So we have 90 degrees here minus this 68.3. You gotta use the calculator here because we're dealing with decimal numbers. So use your calculator. 90. 68.3. 21.7 degrees, right? 21.7 degrees, which is somewhere there, right? This. Can you do the same here for supplementary angles, right? Just remember that for supplementary angles, the angles should add up to 180, right? So this formula becomes just this, right? So try to figure this out. I see. Yeah, Mamadou, let me check. Excellent, very good, excellent, you got it, right? Yeah, so basically we subtract from 180 this given angle, right? To generate our supplementary angle. And this difference turns out to be 68, right? When you use a calculator. So excellent, done. So up, we get to the applications, right? First application of angles measuring radians is this nice formula that allows us to compute the arc length, right? The arc length, the length of this arc. The formula, if you don't remember, is given here, S equal R theta, where theta must be in radians, right? But somehow in this particular problem, I got lucky and the angle is in radians, right? How do you know, Professor, that this angle is in radians? Well, first of all, doesn't have the little circle on the top. And second of all, when the units are not written, mathematicians have this agreement, the angle then it's in radians, right? It's in radians. And third, I see pi. When you see pi, guys, 99.9% that the angle is in radians. So pi over 3 is the angle. I can substitute directly. The radius is given is 16 inches. So this is what you gotta do in your calculator, right? So this requires a calculator, right? So 16 times pi. Pi is here, or you can just type pi, same, divided by 3, right? Or you can write 16 between parentheses, pi over 3 is the same. But what is important, you should get this, 16.75. Follow the instructions for the rounding. They say round to 2 decimal places. So you go up to here, right, up to 2 decimal places. But since this guy is 5, the rule says we have to add 1 unit here. So 16.76 is what you have to consider, right? 16.76. In the end, you may attach the units. We are dealing with inches. So inches, right? So this guy. Can you try number 13? Do this. It's similar, but I think you have to be careful the angle there, but it's not in radians, so you have to convert it to radians first, right? Try. Yeah, as a hint, the formula is given, right? S equal R times theta, where theta is in radians, right? Very important here. And you need the calculator here as well, right? Yeah, we're trying to compute this arc length, but now the angle is in degrees, so convert it to radians and then use the formula. Yeah, that's the arc length, right? Yeah, there we go. Yeah, try guys. And try to use your Desmos scientific calculator. It's available there in our website, right? And do the rounding also following the instruction, right? Round to 2 decimal places your answer, right? Okay. All right, let's do it together. The radius is 6 inches, right? The angle is not in radians, but it is not hard to convert this angle to radians by multiplying the angle by 180 degrees here, 2 pi radians on the top, right? So this whole multiplication will be the angle in radians, which is what I need, right? So I'm gonna do this in the calculator. So get your calculator. I see students figure this out. Regine, let me check. Regine, very good. You got it. Excellent. Good job. Yeah, very good. So I'm gonna do 6 times. Notice how I use parentheses, so I don't have to type the multiplication symbol. Times, well, here probably I can type it. Multiplying fraction form 2 pi on the top and 180 on the bottom. Yeah, type this nicely. So do that, you get the right answer, right? Yeah, close parentheses and it's there. 28 point.
I'm sorry. Where did the 2 come from for 2 pi?
So I'm sorry. I'm so sorry, Regine. It's just a pi. Not 2 pi. It's pi. Thank you. It's this pi, guys, right? Yeah. It's just pi. So we're going to erase this here. So this should be the answer, right? 14.13 rounded to 2 decimal places, 14.14. Very good. Very good. 14.14. Let's erase this unnecessary number 2. It's just pi, right? Pi is 180 degrees, 14.14, right? Rounded to 2 decimal places. In the end, we attach the units is this. Great. Excellent, right? Yeah. Very good. Next, application to compute the area of sectors, right? Think of this as the slice of pizza, right? And the goal is to compute the area now of the slice, right? Now, they are not giving you the formula, so make sure, guys, that you have available this formula. Not S, A now, A, area formula, right? Area formula, the area of a sector, I know it by heart, is 1/2 R squared times theta. 1/2 R squared times theta, okay? Where theta is in radians, very important, okay? Is in radians. All right, so let's do this, right? Area equal 1/2 radius. Radius is 25 meters, must be squared. And then theta in radians. Theta, I got lucky, here came in radians. How do you know it's in radians? Well, you see the little circle. You see just this value. So mathematicians then have this agreement, this should be in radians. So this is it then, right? So you just put this in your calculator, 1/2, 1/2, multiplying 25 squared. And that multiplying 2 pi over 3. And what you get should be rounded to 1 decimal place, right? So I guess 654.49. That rounded to 1 decimal place is 654.5, right? 654.5 is there. Is this guy, right? 654.5. In the end, feel free to attach the units. They're dealing with meters. The area should come out in square meters, right? Can you try this one? Number 15. Yeah, so I'll finish with this probably. I will write out the area for you in case you don't remember. Area 1/2 R squared times theta, where theta is in radians. Yeah, go ahead. In case you don't see this well, I can make it bigger. That's better, I think. Yeah, now everybody can see it. Yeah, radius 13 feet, angle 20 degrees. But remember, you are converted to radians, right? For the formula to work.
Or we could just put the whole equation on a calculator.
Yes. You need a calculator, Sergio, because it's a decimal number. We are not going to get it by doing it mentally, right? Yeah, calculator. Yeah, let's try to start with this. So 1/2 radius square. What is the radius? They say 13 feet. I see. The student figured it out. Let's see. Regine, very good. Yeah, you made my day, Regine. Excellent. Very good. Excellent. Good work. Good work. Great. 13 square. And here we are supposed to write the angle, but in radians. It's in degrees, but that shouldn't be a problem, guys, because we know how to convert degrees to radians, right? We just multiply by this ratio of this rate, if you want to call it, right? This conversion factor, 180 on the denominator, pi radians on the numerator, right? It is my intention to eliminate degrees here. So that's why I'm writing 180 on the denominator. More students figure this out. Sergio, yeah, Sergio, good work. Yeah, you got it. Yeah, we're headed there. So now this guy will be equal to what? Well, this has to be done in the calculator, guys. No mental mathematics is going to take you to the answer because there's a pi here. This is an irrational number, right? Yeah, so you do 1/2 here, 1/2 over 2 times 13 square times parentheses, right? Notice how I use parentheses to make sure that I'm doing the right thing, right? Times here, pi is this guy, or you can type pi is equivalent. Yeah, so either way, divided by 180 and then close parentheses. The answer will come out here. Notice there is no way to convert this to fraction because the reason is because of the pi. This is an irrational number. So, but whenever possible, you can use that, right? Yeah, great. Okay, so now this is the answer. They wanted to round it to 1 decimal place. So you go up to here, notice 29.4, but the rule is, right, if this number next to 4 is bigger than 5 or equal to 5 even, you are at a unit here. So the rounded answer should be 29.5, 29.5. Okay, so let's do that, 29.5. And in the end, you feel free to attach the units. We are dealing with area, so this should be feet squared, right? Feet squared. 29.5 feet squared is here, right? Excellent, excellent, guys. Okay, guys. It says use the given trigonometric function value of theta to find the requested trigonometric function value of the acute angle. Acute angle, very important, this information. Acute angle, right? Theta. Rationalize the denominator where necessary. Why is this important? Well, but this is telling us that the angle has a measure between 0 degrees and 90 degrees, right? So it's a small angle. A small angle, and the sine of that angle is 4/5, which means that I may assume that the angle is on the first quadrant, right? Or I can just assume that the angle lives inside some right triangle, right? Such as this. And remember this technique, we said, recall what sine is, right? By perhaps remembering this mnemonic device, SOHCAHTOA. This part, so says sine opposite over hypotenuse. So this is opposite, this is hypotenuse. So when you make up your triangle, let the hypotenuse be 5, let the opposite be 4, right? 4. Now the base is missing, Professor. I know, but we can find it, right? We can find our base that is missing to complete our right triangle via the theorem of Pythagoras. B squared plus 4 squared equal 5 squared. B squared plus 16 equal 5 squared is 25. Subtracting 16 in both sides, B squared equal 9, right? This difference. And then B will be the square root of 9, which is just 3. B equal 3. Once you know the value of B, place it here. And now you will have access to any trigonometric function of theta, right? Because we have completed this right triangle. So in particular, you can know, or you can figure out what is tangent of theta, right? Tangent of theta. Again, from SOHCAHTOA, look at this TOA part. This is saying tangent opposite over adjacent, right? Opposite over adjacent. So then look at your right triangle here. Opposite is 4, adjacent is 3, right? 4/3. Positive because it's an acute angle theta, right? So 4/3 should be the answer to this problem, okay? Very good, guys. So now this one is similar. The only difference is that they're giving you now cotangent, but cotangent, according to SOHCAHTOA, should be the reciprocal of tangent, right? Tangent is opposite over adjacent. This cotangent should be adjacent over opposite, right? With this information, you can construct your triangle as I did before. And then you should be able to go through this. Let's take a look at a different form. Let's take a look at 18. For question 18, they say simplify this expression, this trigonometric expression, right? Tangent of theta multiplying cotangent of theta minus cosine of theta. And one strategy that I suggested on the lecture is rewrite tangent and cotangent in terms of sines and cosines, right? What is tangent in terms of sine and cosine? Anybody could tell me in the chat what is tangent equal to?
Sine over cosine.
Excellent, excellent. I see. Very good, right? Sine over cosine, sorry, sine of theta over cosine. So this is something that you should at this point have memorized, right? Because it's very useful, right? It's also on our sheets, I believe, but this is tangent always, right? Sine over cosine. Excellent. Now, similarly, what should be cotangent of theta in terms of sine and cosine? Anybody could tell me in the chat or could write in the chat cotangent of theta equal? Yeah, very good, right? Yeah, it's the reciprocal cosine over sine. Very good, Regine, right? It's the reciprocal of this tangent, right? It's what you get when you flip this tangent, and then you get cosine of theta over sine. And there is even a sheet, the unit circle sheet, where this is written, right? So it's there. So rewrite that as cosine of theta divided by sine of theta. Once you do that, guys, multiply over, right? Multiply over using the distributive property. And you will see that is cancellations will come along, right? There will be ways to simplify this. Minus, minus, here sine of theta over cosine of theta. Multiplying this cosine of theta, right? But what is this equal to once you cancel cosine and cosine, one on the bottom, one on the top, right? Sine and sine also cancels. But now notice, sine divided by sine is 1. Cosine divided by cosine is 1, right? So 1 times 1, this is just 1, not 0, right? 1. Minus here, cosine divided by cosine 1. 1 times sine, sine, right? 1 minus sine of theta. And that's pretty much it, I think, because then you see that the answer is here, right? Very good. Very good, guys. Moving on to 19. This one, another simplification of trigonometric expressions. We just agree that tangent is the same as sine over cosine, right? So we're gonna write it here as sine of theta over cosine of theta, right? That is for tangent, right? Who can tell me what is secant in terms of sine and cosine? Secant of theta in the chat or verbally, you can tell me secant. What is this as a fraction between in terms of cosine or in terms of sine? Anybody? I will give you a hint, right? Secant is the reciprocal of cosine, the reciprocal of cosine. So since it's the reciprocal of cosine, it should be gotten by flipping cosine, right? So 1 over cosine of theta, right? 1 over cosine of theta. Yeah, now guys, if you have difficulties recalling these facts, I would strongly recommend you to have this printed out when you take your exam or when you do your homework, right? And look at these guys, look here. The one that I wrote, secant 1 over cosine is here. Secant 1 over cosine, right? Cotangent, cosine over sine. It gives you a lot of information, this part, right? That is what we're using. Okay, great. All right, 1 over cosine. So now you write here 1 over cosine. Now you are supposed to divide this fraction, sine over cosine, by this fraction, 1 over cosine, right? But the way you divide fractions is this. You keep the fraction on the numerator as it is, and you multiply that by the reciprocal of the fraction on the denominator, right? Or the fraction that you get when you flip this fraction, right? So notice now then that cosine and cosine will cancel. Cosine divided by cosine 1 times sine, right? Sine of theta. That will be the final answer. Very good, guys. So That was 19, right? This one I will leave for you to do at home, similar. Just express tangent as sine over cosine, do the cancellation, you should get the answer. Number 21. This one deals with using what is called the Pythagorean identities, right? Pythagorean identities. Pythagorean identity, professor. Yes, look at this. Sine square plus cosine square. Who can tell me what is sine square plus cosine square in the chat? At this point, you might have memorized this, or you look at the sheet, right, that I just showed you. One, excellent, right? Excellent. One, excellent. Sorry. So one, right? That is one. But there is a tangent square of theta plus one, because this tangent is this guy, right? But what is tangent square plus one? Tangent square plus one. Look at your sheet, or you may have secant square. Excellent. Secant square is the one, because look, it's here. 1 plus tangent square, or tangent square plus 1, same amount, right? Is secant square, right? If you don't remember, always look at your sheet, secant square. So this will allow you to simplify that. Secant square of theta, right? And we're done. There you go. All right, this one is similar, but since it deals with a quotient, probably we can do it quickly. They say here cosine of theta square over sine of theta square. Allow me to rewrite this as this, okay? I just put the square outside, okay? And you may say, why you are doing that, Professor? I will show you next. Now, cosecant, remember, is the reciprocal of sine, right? So 1 over sine, 1 over sine. Sine there. Notice how I'm rewriting everything in terms of sines and cosine, right? That 90% of the time will help, guys. It takes sine and cosine kind of as building blocks, right? Write everything in terms of sine and cosine. That 90% of the time will help. All right. Now notice, what is cosine over sine? Cosine over sine is just tangent, right? Tangent of theta. And then this is a square. So I'm going to square my tangent. And this one, notice sine divided by sine is just the number 1, right? The number 1. So we end up with tangent square plus 1 again. But we just said that this tangent square plus 1 is just secant square, right? Secant square. And basically we are done. Very good, guys. So, that's it. This one I will leave you for you to do at home. Yeah, go ahead, Ray. Sure.
The last one,
cotangent. Yeah, cotangent.
Yeah.
Sorry.
So
Yeah,
then it's cosecant,
sorry.
right?
Yeah, then it's cosecant. Thank you, Regine. Yeah, cosine over sine. Remember, sine over sine tangent, but cosine over sine, very good, Regine, is cotangent, right? So this is going to change a little bit things, because this has to be cosecant. Excellent. Very good. Let's check that out. Excellent. Cosecant square, and that will lead to this guy instead, right? Yeah, be careful, guys, with the choices, are very tricky. Yeah, yeah, very good, Regine, very good, nice catch, right? Yeah, this is it, cotangent. Excellent. Moving on, let's 23, right? Let's do this quickly. Yeah, sine of theta multiplied by cosine of theta divided by tangent of theta. But tangent of theta, we said, is sine of theta over cosine of theta, right? According to the reciprocal identity. And now, as a divisor, the way you divide a quantity by a fraction is this, right? As a divisor, this must be flipped, right? You flip the divisor, and that gives you cosine of theta, sine of theta, and you multiply, right, instead of dividing. So that's how you handle division by fractions. But when you do this, notice sine and sine, they cancel. Cosine times cosine, cosine square, right? Cosine square of theta. Remember, mathematicians place the square in the middle, on the top. Excellent. Now, that's it, right? Great. Excellent. Yeah. Very good, guys. Okay, so now these are computational, right? 3 questions computational. I'm gonna just do a few. Let's do the first one, right? In the calculator, can you figure out what is sine of 42 degrees and round it to 2 decimal places? two decimal places, right? Rounded. Yeah, go ahead. So you take your scientific calculator. I strongly recommend you to use this Desmos scientific calculator. It's OER, free for you to use. And is well fitted for this course, right? Yeah, sine of 42. Students are posting answers. Very good, Ray. Very good, right? Yeah, very good. Yeah, so excellent rounding, right? Excellent. Yeah, 0.067 because you have to round it to two decimal places, right? That's what the instructions are, two decimal places. So this 6 becomes a 7 because of this 9, right? 0.67. That's it. Now notice how I am keeping this computation in degrees, right? Why you're doing that, Professor? Because this is a little hollow circle on the top saying degrees, right? So it has to be in degrees, right? Great. So 0.67. That's it. Done, right? 0.67 rounded. And then you go this. 24. Excellent. Yep. This one, similar, right? Similar. This is with cosine. This is with tangent. Yeah, you can do it. But this one is a little bit interesting because it deals with radians, right? How to compute this in the calculator? Well, you just have to be careful here, right? This is not degrees. Why you say that, Professor? Well, first of all, you don't see the hollow circle on the top, right? And second of all, when you don't see any units attached to the number, this means by default, it's a mathematical agreement that this is in radians. Third reason, you see pi there, right? Pi, when there is pi there, 99.9%, it has to be radians, right? Yeah, great. Okay, so cosine of this, but in radians. So we do cosine of 2 pi is here, right? Or just type pi, right? Same thing, 2 pi over 5, right? Over 5. Now, don't go with this. This is the result if we work in degrees, right? By default. Click here, radians. This is the one we need, right? This is the one we need. 0.31, rounding to two decimal places, right? 0 becomes 1, 0.31. Yeah, excellent, guys, excellent. 0.9. So be careful there, okay? When it's in radians, work in radians. When it's in degrees, work in degrees. Excellent. So 27, great. Moving on, computation, right? This one deals with find the height of a pine tree, knowing that this pine tree, due to the sun, gives us a shade, right? And this is 45 feet, right? The shadow on the ground. And assuming that the angle of elevation, right? Here is 69 degrees. How could you compute the height of the pine? Call this h. We don't know what it is yet. We will find out, right? But what function can you use to find h? Anybody? What trigonometric function? Is it sine, cosine, tangent? What would be proper to use here? Anybody could write on the chat or say it? Regine, yes, sine. But the problem with sine, Regine, is that, remember, by Sohcahtoa, sine is opposite over hypotenuse. We don't have the hypotenuse, right? So any other trigonometric function?
Tangent.
Tangent, very good. Tangent, because tangent is perfect, because tangent is opposite over adjacent. Opposite, adjacent is going to relate these two, right? Tangent of 69 degrees. Very good, guys. Tangent of 69 degrees should be equal to opposite, according to Toa, right? Opposite h over adjacent, right? 45. Very good, right? Assuming this is a right triangle, of course. Yeah, then after that, tangent of 49 degrees is 69 degrees, so right, it's just a number, a real number, right? Let's treat it as a number. So imagine there is a number there. So one thing I can do to solve this equation is to multiply both sides of this equation by 45. And doing that, I get rid of this 45 and I get my height completely isolated. 45 multiplied by the value of tangent of 69 degrees, right? But what is that? Because they want this as a decimal, right? You see the choices, and moreover, they want it to be rounded to the nearest whole number, right? No decimals here. So let's do that. So this guy in the calculator is this. Use your calculator. Someone is wrote something in the chat. I will read it next. Tangent of 69. Notice I'm using degrees because of this, right? Degrees. 117.22, but rounded to the whole number, to the nearest whole number, this should be just 117, right? 117, which should be the answer, 117. And in the end, feel free to attach the units, feet, right? 117 feet. I see someone wrote something on the chat. Tangent, yes, Regine, very good, very good. Yeah, good. I'm glad that you realize it's tangent, right? Because we know this guy and we know this guy, right? That's the reason, right? That's the only reason we chose tangent, right? We don't have information for this guy, for the hypotenuse, right? Yeah, very good, very good. Yeah, very good, very good. Yeah, so great, great. So now, guys, let's continue, right? Let's continue here. 29. A kite currently flying at an altitude of 13 meters. This is a kite, but it's similar to this one, but probably we can quickly do it. Yeah, it's a little bit different, I think. Yeah, this is a kite. Someone is flying a kite. And the altitude is given. A kite is currently flying at an altitude of 13 meters, right? So the altitude of this kite is given is 13 meters. The angle of elevation here, 32 degrees, right? Yeah, 32 degrees. Find the length of the kite string to the nearest meter. The length, right? The length, this length. I don't know what it is. I will call it C, this length, right? But now, question for you guys, right? When looking at this triangle, what trigonometric function do you think would be appropriate to relate C, what we're looking for, and 13? Is it sine, cosine?
This one is sine.
Or tangent? This one is sine. Excellent, Regine. This one is sine. Yeah, excellent, because look, sine, according to the opposite over hypotenuse. Opposite over hypotenuse. Excellent, right? Sine. Excellent. Very good. 32 degrees sine. Opposite 13 over hypotenuse that I don't know, C, right? So I can solve for C and figure out what is C. Now, this is just a number, guys. It's a number, a real number, some decimal there, right? Treat it as a number. So you have a number there. One thing you can do is you can multiply both sides of this equation by C, That way, this C is going to appear over here. Okay, so we're going to have here C multiplying sine of 32 degrees, which is as a number, right? Equal here, cancel 13, right? And moreover, since this is just a number, I may allow myself to divide both sides by this sine of 32 degrees, right? And therefore find the answer, right? C equal, canceling these two, 13 over sine of 32 degrees. Calculate that in your Desmos scientific calculator or in any calculator that you are using, scientific calculator. So this is this. Notice I'm working degrees, right? For the word problems, often that's the case, right? And I get this 24.5. Now they want you to round this to the nearest whole number, right? So round it to the nearest whole number, that should be 25, right? 25 meters. So that's it, 25 meters. And that should be it. In the end, you may attach the units, right? Meters. So this guy, this. Let's finish this with this. There is a river. They're asking you to figure out what is the width of this river, right? We don't know what it is. I'm going to write for this X or Y, any letter of the English alphabet will work, right? But now, anybody could tell me what trigonometric function I should use for this situation? Tangent, sine, cosine. What would get us to the answer for this? Anybody?
Tangent?
Tangent. Excellent, excellent there. Very good, Rayin. Tangent, right? And because tangent, according to TOA, is opposite or adjacent. Opposite, adjacent, right? So tangent, use tangent for this river problem, right? Other translations are not gonna help you. Tangent, opposite over adjacent, right? Multiply both sides by 95, right? And that should lead us
Which
to the answer.
which one? We work in X with
I'm calling this
95.
X, Sergio. I call it X. I could have called it B, A, any letter of the English alphabet, right? You are okay now?
Oh, I see. I see
Yeah,
95. I didn't
yeah,
see that.
yeah. The 95 is down here,
Got it.
given, right? So great, great. Yeah, very good, guys, that you clarify. Great. So X has to be this multiplication, 95 multiplied by the tangent of 35 degrees. And this is something we can get in our calculator, right? So get your calculator, 95 times tangent. Tangent, just TAN, or if you prefer, you click in functions, it's also there, right? Either way is fine. 35, just make sure that you're working in degrees, guys. For the word problems, degrees. So you get the 66.5, right? 66.5. But that should be rounded to the nearest 100. 66.5 rounded to the nearest whole number, sorry. Whole number is 67, right? 67. So 67, this will be 67 feet. 67 feet, which is this guy, right? Excellent. All right, guys, I hope with this you will be okay with the word problems. Let's move on. Let's talk about this other stuff. A point on a terminal side of angle theta is given. Find the exact value of the indicated trigonometric function, sine of theta. Okay, they are giving you a point on the terminal side here, just 15. So let's say this is 15 and this is 20, right? 20 units. Don't worry about the scale, just put it somewhere there. And this is the terminal side, right? This is angle theta. Remember, we have a definition for sine of theta when you work with your angle in a standard form, right? The XY coordinate system, the definition says sine of theta is equal to R. They call this R, this distance, right? R, this is Y, right? So sine is equal to Y over R, right? Over R. But what is that R, Professor? R is the square root of X squared plus Y squared, right? So R can be easily found by doing this, 15 squared plus 20 squared. And notice that this coordinate could be positive, negative, right? But the square will be always positive. 15 squared is 225. 20 squared, 400, right? And the square root of all this is the square root of 625. And you can do it in the calculator, right? And this is just 25.
Professor, is that
Yeah.
is that basically another way of theory of Pythagoras?
Yeah, it's just another way of looking at theorem of Pythagoras. But the thing is, Regine, that right now we kind of got lucky. We ended up in the first quadrant, right? But sometimes you may end up on the second quadrant, third quadrant, fourth quadrant. And this X and this Y may be positive or negative. So there, it might not be clear that it's just a theorem of Pythagoras, right? There will be signs involved, but this is how you do it, right? You find the R is 25, right? And the Y has positive sign because it is 20. So it's just this, right? Yeah, very good. Yeah, but anyway, you can do it. If it's in the first quadrant, you can work with the right triangle. It's okay. It's okay, right? So just do it. And then simplifying 4 over 5, right? 4 over 5, which is this guy. So that should be the answer for 31, right? Great. Let's look at 32. 32 similar, right? I'm not gonna do it similar. Instead, I probably will do 33, which is a little bit different because look, this is X, this is Y, right? X is negative, Y is positive. But still, guys, sine of theta is still Y over R, right? No matter what. And R is still equal to the square root of X squared plus Y squared. Okay, But now, what is this guy? A square root of x is negative 20 here, right? Square plus y is 48. The numbers are big. We're going to use the calculator to help ourselves out, okay? Here, what is this computation? What is negative 20 squared plus 48 squared, the square root of that? Well, let's use our calculator. A square root is here. Then you type negative 20 squared plus 48 squared. You can put it within parentheses, right? It's a good habit, right? Because when the numbers are negative, it really matters. Okay, so 52, right? 52 is the result of all this, 52. So let's take that, 52, and let's put it in here, 52, right? So sine of theta will be y, which is 48 over 52, right? Over 52. Simplify this, divide both by 6, right? For example, right? 6. Or by 2, perhaps better. Even numbers, right? So it's 24 over 26, divide by 2 again. 12 over 13, right? 12 over 13. That's it, 12 over 13, which is this. So for 33, we're good. 12 over 13. Yeah, I see some questions. No, okay, no, never mind. Yeah, great. Very good, guys. So this is how you use this, right? This one's similar. I'm gonna write similar, right? Use the signs, right? Use the definitions for trigonometric functions for any angle, remember, in our notes. All right, now this is a different form, 36. They say, figure out what is the quadrant where theta lies, knowing that tangent is positive and sine is negative. For this, I recommend you to use all students take calculus. Where is tangent positive first? Tangent positive here on the first quadrant, right? All the trigonometric functions are positive here. And also on the third quadrant, because according to all students take calculus, tangent and cotangent positive are right negative, right? This is for tangent. Sine negative, where is sine negative? Not here, because every trigonometric function is positive. Here also sine is positive. So here and here, right? Sine is negative. Third quadrant, fourth quadrant. But where both things happen at the same time, on the third quadrant, right? So then you can say, okay, then this is in quadrant 3. Right here. So the angle should be in quadrant 3. That's for 36.
What they ask again?
They are asking you to figure out where is the angle, where the angle theta lies, right? Is it in the first quadrant? Is it on the second quadrant? Is it on the third quadrant? Is it on the fourth quadrant? Knowing that tangent is positive and sine is negative. You follow, Sergio? I will explain that, like, tangent is positive on the first quadrant, on the third quadrant, tangent positive, right? And sine negative on the third quadrant and on the fourth quadrant. But in which quadrant these two things are true? Only on the third quadrant, right? On the third quadrant here, right? Maybe I can highlight this. Look, in this quadrant, these two things are true, both, right? In no other quadrant, those two statements are true, right? But in this one, the third, so that's why it's third quadrant, right? You follow now? Better?
Yeah.
Okay, great. Yeah, number 37, guys, similar, right? Similar. So use all student take calculus, right? This one's similar, right? Let's try to look for other forms. This one's similar, right? Now this one is different. Find the reference angle of the given angle. Reference angle of 96 degrees. What's that? 96 degrees is where? Is on the second quadrant, right? Why I say that? Because this is 90 degrees. It's a little bit over 90 degrees, right? This is 96 degrees, right? It's on the second quadrant. But now, remember, the definition of the reference angle is this. It's the angle formed, the acute angle formed, the small angle formed by the terminal side of the angle and the x-axis. What is the acute angle formed by these two guys? The x-axis and the terminal side of the angle. Not hard to see that it's this, right? It's this. But this angle is what? is 180 minus this, right? And even gave you a formula in case you want a formula in our notes, right? For each quadrant, what to do. But if you graph it, the angle, you should clearly see what to do. Look, this green angle, right? The reference angle is just in this case, this reference angle.
Professor,
Yeah. Yeah, go
I
ahead.
think I missed it, but so you said to use, did you say to use all students take calculus for?
Oh, for the previous, for this guy?
Yes.
Yeah, any, yeah, so for this part, you want me to explain the
Oh
36
no,
again?
actually even 34. 34?
Oh, 34, yeah, 34, 34.
Uh,
Here?
yeah. So
Uh,
something like for that, for example, would you use all students take
no,
calculus?
no, like here, since the coordinates are given, all you need is really the definition. Remember, when we look at this, the definition of trigonometric function for every angle, we said that secant is what? Is the reciprocal of cosine, right?
Yeah.
So should be cosine is opposite over hypotenuse, or
So it's
cosine.
hypotenuse over adjacent.
Yes, but hypotenuse in this definition is r, right? The hypotenuse is r, right? R
Right.
over x, right? You agree? R over x.
Yes.
Good. And now you find r using your calculator, right? Which is going to be this, right? X squared plus y squared, the square root of that sum, right?
Right.
And if you do that, Regine, I can assure you that you will get the number 5, right? So you
Right.
simply substitute this 5 here. 5 and x. X is -4, right? So you don't need really
Oh,
all
okay.
the student take calculus, right? You just need to put 5 here. And
That's why you were
-4.
saying we have to use this formula instead of the Pythagoras theorem.
Yeah, this formula, because these angles could be angles on the second quadrant, third quadrant, we don't know, right? We don't know,
I see.
right? But if
Okay.
we follow the formulas, then good question, good question. Great, guys. So let's move on. Yeah, that was B.
All right. Thank you.
All right. You're welcome. You're welcome, Regina. I'm happy to answer your question. All right. So now we're saying that here the reference angle should be, right? All this minus 96, right? So compute in your calculator this, right? And there's a formula even for the reference angle on the second quadrant is 180 minus the given angle, right? 180 minus the given angle, which is 96 in this case. And that gives me 84 degrees, right? 84 degrees, which should be the answer for this problem. 84 degrees for 40, right? I will check here. Yeah, we're good. Great, excellent. Now this one, right? Again, the reference angle, 445 degrees. This angle is really big, right? But we learned that we can always take away 360 whenever the angles are more than one full revolution, right? To reduce them to equivalent angles. So if you take away 360, notice what happened. 445 minus 360 is just this, right? Let's compute it here. 445 minus 360. It's 85 degrees, right? 85 degrees, 85 degrees. But now I can just completely work, instead of working with 445 degrees, with 85 degrees, but they're coterminal, right? But what is the reference angle of 85 degrees? Well, 85 degrees is in the first quadrant, right? And on the first quadrant, the reference angle is the same as the given angle, right? In the first quadrant, right? Yeah, so reference angle is itself. You follow, guys? Yeah, reference angle is itself, because the definition of reference angle is the angle formed by the terminal side and the x-axis, the acute angle form, right? And this itself. So, right. So whenever your angle exceeds 360, immediately subtract 360 and work with this guy, right? Whatever it is. So that this tells you this is the reference angle, right? 41. Very good. Maybe here it's a little bit tricky. For negative angles, I would advise you to draw the angle. This angle, 51 degrees, negative 51 degrees, is formed by rotating clockwise, right? Clockwise 51 degrees this way, right? Yeah. This is negative 51 degrees, right? Then here apply the definition. The definition of the reference angle is this. The reference angle is the angle formed by the terminal side, which is this, right? And the x-axis is the acute angle formed by the terminal side and the x-axis. But what is the acute angle form? Acute angle has to be positive between 0 and 90 degrees, right? Formed by the x-axis and the terminal side is just 51 degrees, right? Reference angle, 51 degrees. Reference angle is always positive, right? So take that. You follow, guys? So this one is just this. All right, moving on. Let's talk about use the reference angle to find the exact value of the expression. Let's say you want to find sine of 765 degrees. Notice this is a huge angle, right? So I have to make it smaller by subtracting 360. If you subtract 360, this is going to be 5, this is going to be 0, this is going to be 4. It's still big, right? Still big. So feel free to do this again as many times as you need, guys, because removing or subtracting 360 degrees to an angle in trigonometry is basically generating coterminal angles, equivalence angles to work with in trigonometry, right? So subtract as many times as you want, as you need, better said. So if I subtract again, I end up with 45 degrees, a nice angle, right? 45 degrees. So it's completely equivalent to work with 45 degrees than to work with 765 degrees, right? But if you work with 45 degrees, this guy should be just sine of 45 degrees, right? These two guys are equivalent coterminal angles, right? So, but what is the sine of 45 degrees? Anybody remembers from the unit circle? You can write it on the chat or say it. In exact form, right? In exact form. Let me bring up the
It's
unit
a
circle.
radical 3/2.
Radical, very close, very good. Radical 2, I think, right? Here, you see here, Regine? Radical 2/2, right?
Yeah.
Radical
Thank
2,
you.
yeah. Radical 3/2 for 30 degrees. Yeah, but always check, right? Make sure that you're picking the right. Square root of 2 or radical 2/2. Sine, right? This is cosine. Very good. So radical 2/2, and then we're done. Radical 2/2, which is this guy, right? Yeah, that was for 43. Excellent. This one's similar, but advice, first of all, deal with this negative sign this way. Pull out the negative sign, put it outside of sign, right? We have this property, right? When we deal with sign, this negative sign can be taken outside of the sign function, right? Deal with this. Now, advice, if you don't like to work with 2π/3, you can convert to degrees, or if you just notice that this is a special angle 2π/3, it's in our unit circle, notice 2π/3 is here. Pi/3, 2π/3, you see it? 2π/3, right? This is here. What is the sign of that? First coordinate give us cosine, second coordinate give us sine, right? This is a square root of 3 or radical 3/2, right? Radical 3/2. Radical 3/2. So radical 3/2, don't forget that there was a negative sign outside waiting, right? So this should be the answer, right? For 44, this guy, right? Follow, guys? Yeah, use your unit circle. They wanted it in exact form. All right, next question, 45 says, secant of theta is 9/2. Theta is in quadrant 4. Figure out what is tangent of theta. All right, let's do it together. They say that theta is in quadrant 4, right? So let's place our theta somewhere in quadrant 4 this way. This big angle is theta, right? This big angle is theta. But now, remember, when you have a big angle, bigger than 90 degrees, it is preferable to work with what we call the reference angle, right? This will be the reference angle theta prime, theta prime. Using this theta prime, I'm going to construct here a right triangle, since theta prime is an acute angle, right? Reference angle, right? And in this right triangle, based on this information that secant is 9/2, and I know that secant is the reciprocal of cosine, right? Cosine is opposite over hypotenuse. Secant must be hypotenuse over opposite, right? So this should be the hypotenuse. This should be opposite, right? Opposite. Actually adjacent, right? Because remember, this is Katoa. Adjacent over hypotenuse, right? So this will be hypotenuse over adjacent, right? Yeah, let's fix this. All right, yeah, be careful there. We're dealing with secant is the reciprocal of cosine, hypotenuse over adjacent. So this should be my adjacent 2, and my hypotenuse should be 9, right? We don't know this guy, call it B, for example, right? We will find out what B is by applying the theorem of Pythagoras, right? B squared plus 2 squared in this triangle is giving me what? Well, let's see. This triangle is giving me 9 squared, right? 9 squared. Okay, great. So now B squared plus 4 equal 9 squared 81. Subtract 4 in both sides. B squared equal 81 minus 4 is 7, right? 7. And B will be equal to a square root of 77, right? Yeah. 81 minus 4, 77. Okay, great. Square root of 77 is B. This guy then is the square root of 77. Once you find it, put it there, right? Put it there. Now we completed the triangle. We can find any trigonometric function of theta prime, the reference angle, right? In particular, we can find tangent of our reference angle, right? Tangent of our reference angle will be what? Tangent, according to this TOA, opposite over adjacent. Opposite is a square root of 77 over adjacent. Adjacent is 2, right? That's tangent of my reference angle. But the tangent of theta is in value the same of the tangent of the reference angle. The sine may not be the same. No problem, because we have this, all students take calculus to figure out the sine, right? On the 4th quadrant, tangent is negative because only cosine and secant are positive, right? Tangent is negative, so this has to be negative, right? You follow, guys? So this should be the final answer. For 45, excellent. Yeah, very good. Very good there, right? So use your knowledge of reference angle to figure this out, okay? They wanted the exact form, so you gotta go through this, right? Very good, very good. Okay, let's continue. We reached the unit circle. I'm glad we reached the unit circle because the unit circle simplifies the work a lot. You will see. They are asking you to figure out in this unit circle, right? They say this is the unit circle. This is 1, 1, 1, 1, right? What is sine and cosine of theta? Sine of theta is always in the unit circle the second coordinate, right? This is sine. So the sine of theta will be simply 12 over 13. You just pick the y coordinate up here, right? Sine. Cosine of theta in the unit circle is always given by the first coordinate, the x coordinate, right? Will be minus 5 over 13. And that's all. That's all you gotta do. Thanks to the unit circle, this should be the answers. So we're talking about this kind of.
So we just look at the endpoints.
At the coordinates, at the x coordinate and the y coordinate. The x coordinate is cosine, right? As you can see, Sergio. And the y coordinate is sine, right? Or first coordinate cosine, second coordinate sine. Yes, you just look at the coordinates. If you know that you are working on the unit circle, right? Yeah, that simplifies the computations, right? That's important, unit circle. Okay, this one now, let's see. Let's check this out. Let's put it back. It will come back. Very good, very good. So this one now, Sergio, question for you, right? What do you think should be here, cosine of theta?
Cosine would be 7 over 25.
Excellent, excellent, right? Yeah, I see. This is cosine, the first coordinate. And sine?
Negative 25, 24 over 25.
Excellent, excellent, excellent. You got it, right? You see how powerful this unit circle is, and it simplifies tremendously the computation. So we got cosine and sine basically by just looking at the x coordinate, y coordinate, right? Very good. So then you choose the right one. When you choose, guys, take your time. It's tricky. The choices are close to each other. So make sure you're choosing sine for this, cosine for this, right? They're all flipped. And, you know, yeah, great. Excellent. And all that because it's the unit circle, right? If it is not the unit circle, unfortunately, you have to apply some other methods. But for the unit circle, this is always true. Excellent. Now, another question here, 48 says, compute cosine of negative 180. Yeah, these are questions that you can, for this, you can use the unit circle, right? Maybe I can do just this one. Negative 180 is here, right? In the unit circle, negative 180. I'm going clockwise 180, and then you just look at the coordinates, right? Knowing that this is 1, 1, and 1, this is negative 1,0. So this is telling me that the cosine of negative 180 degrees must be the x coordinate of this point, right? So it must be negative 1, right? Follow, guys? 48, that's it. And similarly here, right? Just look at where 270 is here, use the coordinates, so similar. This one perhaps may cause some trouble, so let's do it. What is the answer for cotangent? Cotangent, you know, is cosine over sine, right? Cosine of this guy over sine of this guy, right? And sine or cosine, I know them because thanks to the unit circle, right? I know what they are once I set my 270-degree angle here, right? And look at the x coordinate and the y coordinates here, right? 0, negative 1 is what are the coordinates of this point. So cosine should be the first coordinate, the x coordinate, and sine should be the second coordinate, right? Or y coordinate. 0 divided by negative 1, 0, right? 0. So we're talking about this, right? You follow, guys? So do this is similar, right? So let's follow another, or let's go over a different form. This is similar. We reach this part, the graphing part, right? Yeah, and when if a question like this appears, right, 4 graphs, and they're asking you for a sequence of pairings, right? Try to do this in order, right? It's not that you have to choose here, 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 or here. It's instead on the bottom here. Look, the right pairing. So let's say you start with y equals sine. Where is y equals sine? Well, look for where the graph of this is, right? Remember, sine is like a wave, right? With period 2 pi. So it's gonna be this, right? It's gonna be this sine. This is the graph of y equal sine of x, right? So this is telling me that let's write here the right sequence, right? 1 should be identified with the graph C, right? With the graph C. 1 with C. So we took care of the first one. Now let's take care of number 2. Y equal cosine. Where is cosine here? Remember, cosine look like a V as in Victor starting at 1, right? Like this, like a V as in Victor. Let's look for that. Here, right? This guy, V as in victory, right? With period 2 pi, right? So they should be 2, right? So 2 should be associated with A, the second pairing. Third pairing should be what? Third pairing, let's say we look for y equal minus sine. Remember, sine compared to minus sine, they are just reflections of each other, right? Reflections of each other. Let's use this color, right? If this is sine, minus sine will be the reflection about the x-axis of sine, right? This will be the equation of y equal minus sine of x, right? So this is telling me that 3 goes with what? Goes with C, right? C. And finally, the last one, 4, is minus cosine. Minus cosine is what you get when you flip this guy, right? Minus cosine. So let's use this. Minus
So
cosine.
more than
Yeah, go ahead.
one. Oh, so each graph can have more than one formula?
No, there must no. So sorry. This one is not really C, because this one, yeah, did not. It's unique, the pairing. This graph is where?
Yeah.
It's here, right? It's here, right?
B.
Yeah, very good.
Okay.
Yeah, it's B. Yeah, very good comment there, Regine. Yeah, this is the one, right? So 3 should go with B, right? Yeah, very good, right? Yeah, because I just use this to show that it's a reflection, right? But in reality, this is the graph, right? This is the one. Y equal minus sine. Yeah, very good. And then number 4 is this y equal minus cosine. Cosine is this, right? So if you flip it, if you don't flip it, I think if you take that reflection about the x-axis, you will get a v backwards here, right? And this is what is shown here precisely, right? Look here. Here's the v backwards, opening downward, right? This is y equal minus cosine of x. And this should be the one that you have to pair up with 4, right? 4 gets paired up with D, right? Now clear, Regine, everything good now? This is the now. This is with a vertical shift, also similar, right? Let's try to get to this part where you have to do this independently. Yeah, similar. Just one graph at a time. Yeah, similar. Here, for example, right? They say graph this, for example, right? That this is different. So how do you graph this guy? Remember, I gave you a technique to deal with this form. It's about finding the amplitude and the period, right? Finding the amplitude and the period. And you may say, Professor, amplitude and period. Yes, there is a way to find the amplitude and the period of this guy, right? This we call A, and this guy we call B, right? And we have this formula. Amplitude is always equal to the absolute value of A, right? But the absolute value of A here is the absolute value of phi. So the amplitude is 5, right? 5 units up, 5 units down are the boundaries for this sine graph, right? Now the period, what's the period? Period is equal to 2 pi, the period of the sine function in standard form, right? In its basic form, but divided by b, right? But b in this case is 2. So 2 into 2, 1. So this is pi, right? This is pi. Very good. Now I have amplitude 5, period pi. So with that, I should be able to graph this function, right? So if you graph it, you start with this, right? We can graph it there. We have like you say up by 5 is the maximum right here. I will go up to here, and minimum minus 5, I will go up to here, right? I think it's there in the middle, right between these two. All right, so then you say, okay, a period of this function is between 0 and 2 pi, right? So up to here should complete the period. And then you divide this in 2 parts. Here is one part, is another part here, right? One thing I strongly recommend you to do is probably you can draw this perpendicular here, it's perpendicular here. And then there, recall the shape of sine, right? Sine starts with 0, goes up to reaching a maximum here, right? Then comes down to 0 intersection, right? Then reaches a minimum down here, right? Then again, intersection, right? So this should be it, right? Important point here, 5 minus 5. This is it, right? So look for that among the choices, and you can see clearly that that is given by this guy, right? Look up to 5, down to 5, closing this at pi, right? I should have done this closer because now my period is pi. So let's shrink it down. This should have been, I should have just, it's going to be very difficult to graph it here, but I will do it anyway. The new graph has period just pi, right? So pi, here it is pi. So basically you have to restrict yourself to this part. Yeah, this is the half, and this is another half, right? Yeah, difficult to graph there, but the idea is that you go up here, reach a maximum, intersection, minimum, and intersection again, right? It should look like a wave like this, right? But when you look at the choices, you will see okay, up to pi, this is pi, right? This is the one, right? Look, you go up to the maximum 5, come down intersection, minimum -5, and come back to pi, and you close your period, right? Because of this pi. You follow, guys? This one D. This one's another one with cosine now. And for this one, I have to tell you this quickly. When you deal with cosine, remember, cosine of negative alpha, let me recall, cosine of negative alpha is always equal to cosine of alpha. Cosine doesn't care about the sine of the angle. When you deal with sine and tangent, you take this out, right? But for cosine, you don't. This is the same as this. We show it with a unit circle, right? Remember in the lecture. So immediately change this for this, because the formulas that I gave you for computing the amplitude and period, they work when this guy is positive, right? This guy could be negative, but this positive. So trade this for this. They are the same. All right, period and amplitude, right? Period and amplitude. Amplitude will be the absolute value of this guy, 5/2. But that is just 5/2, right? That's the amplitude 2.5 if you prefer, right? 2.5 units up, 2.5 units down. Will be upper bound, lower bound for this graph, right? And the period will be 2 pi, remember, divided by b. But what's that? 2 pi divided by b. Be careful here. B is 1/2, right? 1/2. It's tricky here. You are dividing by 1/2. But what happens when you divide by a fraction? You really end up multiplying by the reciprocal of a fraction, right? So this will be 2 pi times 2/1. So 4 pi, believe it or not, the period is 4 pi. 4 pi is a long period. So you look for a graph that is showing 2.5 up, 2.5 up, look like this, for example, right? 2.5 up, 2.5 down, right? This one too, this one, they're all showing that, but now the period 4 pi, 4 pi. This is a period for 4 pi, but the V backwards is not what I'm looking for. I'm looking for the B in this form, right? Look, this will be great, right? Let's do it just here because graphing it over there might be difficult. So I'm choosing this because look, 2.5 up, V as in victory shape for cosine, right? 2.5 up, 2.5 down, and not only that, the period, look, the period 4 pi, consistent with this, right? Follow, guys? This is the graph. Great, that's for graphing, right? This one's similar. So I'm gonna notice this negative sign will indicate that when you are done, you have to reflect your graph, right? Reflection. Reflect. All right, so I will say similar. And we'll continue here. Tangent, now maybe we should take a look at tangent. What is this? Y equal minus tangent. Recall that when you deal with the graph of tangent, you will recall, we explained that the graph of tangent looks like this, has a period pi, half of the period to the right, pi/2, half of the period to the left, minus pi/2. There you draw these two perpendiculars. There will be the vertical asymptote of the tangent graph, right? And the tangent graph looks like a chair where you sit when you're tired, right? Like a chair here. And there are infinite many chairs to the right, to the left, right? But this is what happens over a period of pi. But now they want minus tangent, right? This is the graph of y equal tangent of x, right? Tangent. Minus tangent of x will be just a reflection of this guy about or over the x-axis, right? Why you say that, Professor? Well, because notice, right? Whenever this is positive, because of the negative sign, this piece will be negative now, right? Will be negative. And if this piece is negative because of the minus, this piece will be positive. So still you will get a chair, but you will get a chair, a decreasing chair. Well, it's called a decreasing chair, right? When it's positive here, negative here, when it's negative here, positive here. So this is the graph of y equal minus tangent effect, right? You follow, guys? This, right? Look for that. This one looks good, right? Look, chair in this shape, right? And minus pi over 2 half of the period, pi over 2 half of the period to the right. So I think it's 8. Let's double check. 460, perfect, 8, right? 8. That. Very good. So here is another one. This is a positive tangent. So here, I think it's just basically this. The number 3 is just stretching vertically the graph of tangent of 2x, right? Remember, there's a formula. This is b. The amplitude, tangent doesn't have an amplitude, right? Doesn't have upper bound, doesn't have lower bound, but has a period. And the period is pi over b. B in this case is 2. So the period is pi over 2. And remember, the idea is to go to the right half of the period, to the left half of the period. But what is 1/2 of pi over 2? 1/2 of pi over 2 is pi times 1 pi, 2 times 2, 4, pi over 4, right? So you gotta go pi over 4 to the right, pi over 4 to the left, right? Half of the period, right? So you will encompass the whole period pi over 2 between these two vertical lines. All right, and then the chair, since this guy is positive, is just the increasing chair, right? It's just a very, very steep chair, right? Because of the factor 3 of enlargement, right? So look for that here. Clearly here could be, right, this one, because it's pi over 4 here, pi over 4 negative here, right? Perhaps this or perhaps this, but which one, Professor, which one? Well, in order to see which one is the one, notice that what should be the next point here? After pi over 4, which is 45 degrees, comes pi over 2, right? 90 degrees. Pi over 2 will be the next here, right? The next vertical line here. So the next chair will go like this, right? The next chair, right? And then here will come some other vertical lines into right. So the next chair will go to this, right? 0, pi over 2, pi over 4, pi over 2 here, right? So because of that, I think it should be this one, this one. The one that is crossing, this one, right? Okay. Let's double check here, 61. We are great, we're good, right? Yeah, because of this point, this pi over 2, pi over 2. This is not saying the graph is not, the chair is not going to pi over 2 here, right? Okay, great. Okay, guys, let's move on. We reach this part of sine inverse trigonometric function. What is sine inverse of square root of 3 over 2 in exact form? For that, guys, have ready your unit circle sheet by looking at this, right? What is the angle whose sine is square root of 3 over 2? Look here. I found one angle whose sine is square root of 3 over 2, 60 degrees, pi over 3, right? And it's on the first quadrant. Remember, for sine inverse, we are allowed to look for angles between pi over 2 and minus pi over 2, right? This is where you look for those angles. And clearly, I found one angle here. So this should be just pi over 3, right? Pi over 3. Right, you're answering radians. That is what mathematicians expect you to do, right? Not in degrees, but in radians, pi over 3, right? You follow, guys, for 62, pi over 3. Yeah, great. Next, cosine inverse, same idea, right? You go to the unit circle and it should be there. Yeah, so this, I think is, if you see at the unit circle, this should be just pi over 4, right? Why you say that, Professor? Well, here, look, what is the angle whose cosine is square root of 2 over 2? I found one here, right? Remember, for cosine, we are allowed to look for angle between 0 and pi, right? Between 0 and pi. I found one angle here. Square root of 2 over 2 has, this angle has cosine square root of 2 over 2, so that should be it, right? Pi over 4. Remember to write your angle in radians for inverse trigonometric function, right? So this is this.
So,
Yes, go ahead.
Professor, I think I forgot. What is it that the inverse does? Does the
Oh,
inverse change anything?
The inverse, what the inverse does is this. Look, think about this reading. Sine of pi over 4. What is that sine of pi over 4 according to the unit circle? Is the square root of 2 over 2, right? Correct?
Yes.
That's cosine also, right? Cosine. We're working with cosine here. Let's write cosine here. So cosine of pi over 4 is the square root of 2 over 2, right? This
Okay.
we agree, right? Yeah, but the idea of this cosine inverse is to say
Oh,
this in
yeah.
reverse.
Okay.
In
I
reverse.
forgot.
Yeah, so you
Now I
you
remember.
put this here. Yeah, now you remember. It's
Yeah.
just say this in reverse. This should be pi
Right.
over 4. Yeah, if it helps.
Thank
Yeah.
you.
Yeah, that's it. You switch. Very good. Great, guys. So this one's similar. Try to do it at home. Similar advice. Change this for 0.5 for 1/2 because it will look, you will see in the unit circle, right? Looking through, and this is 30 degrees, but 30 degrees in radians, pi over 6, right? Pi over 6 of this guy. This similar, right? Okay. Let's reach some, then we reach to this part where you have to use the calculator, right? How to compute this with a calculator when they don't care about the exact form, when they just want the answer in decimal form. So this is done using the Decimal Scientific Calculator. You go to cosine inverse. Professor, I don't see cosine inverse here. Click in functions and it will appear there. Cosine inverse is there, right? Cosine inverse of negative 0.3. I'm talking about the cosine inverse of a real number, right? So this will give you the answer in degrees, but remember, mathematicians want this answer for inverse functions of trigonometric functions in radian always. So go for this. Click on radians, make sure your calculator is working in radians. So 1.875, right? They want you to round it to 2 decimal places. So this should be 1.88, right? 1.88. So go for that, 1.88. You follow, guys? With a calculator, right? Try this in your calculator, tangent inverse of 2.2 now. We're using the calculator, right? Why we're using calculator? Because it says here, right? It's indicated, use the calculator. And round it to 2 decimal places. Tangent inverse. Yeah, using the calculator here. Yeah, tangent inverse of 2.2. Yeah, let's do it together. Yeah, so tangent inverse. Where is tangent inverse, Professor? Click in functions, they will appear there. Tangent inverse, right? Tangent inverse of 2.2. Make sure, guys, that you're working in radians. So this should come out in radians, 1.14 radians, right? Rounded to decimal place is 1.14, right? Rounding up to here. Very good, 1.14. Very good, Mamadou. Very good, excellent, right? Very good, very good. I see. Yeah, very good, excellent. This one, 1.14, right? Yeah, 67. Excellent. Yeah, so with calculator, I think it's not that difficult, right? So you will figure this out. Let's just go back to where. Yeah, so great. So let's just make sure it's back. Yeah. Yeah, okay. So let's just make sure it's back. Yeah, it's back. All right, great. So moving on. Let's write it. Moving on. More questions that you can play with using the calculator.
Wait,
Similar. Yeah, go
For
ahead.
68, would you take out the negative and then do it and then put the negative back?
Well, Regine, they are saying here, use the calculator, right? Why don't we just let the calculator do the whole work, right? Let's put this in the calculator, right? Let's do it together. Look, let's put the whole thing with sine in the calculator. You cannot take this out easily because it's sine inverse. With sine, I said, well, it's sine. If it's sine, you take it out. But with this, just I would suggest put the whole thing in the calculator, sine inverse, because they are asking you to use a calculator, right? So minus sine inverse, but recall it's sine inverse, not sine. So we have to click here on functions first, sine inverse of negative 2/7, right? 2/7.
2.9.
And let's the calculator do the
I mean,
work.
0.29.
Yeah, but then in radians, right? I have negative 0.29, negative 0.29. All right, negative 0.29,
okay.
and it's this one, right? D,
Yeah.
right? Okay, excellent, excellent. Very good, good question there. 0.29. So if the calculator is used, it shouldn't be a problem. Yeah, this one the same. All right, now you reach to this point, right, where you have to do some composition between functions here, inverse functions. I said, right, when the angle is in the right place, you just cancel these two, but this is not in the right place. Remember, for cosine, you have to look for angle between 0 and pi. This is not in that range, right? So you gotta do it kind of one at a time. So what is this cosine of minus pi/3? Cosine of minus pi/3, since cosine doesn't care about the sine, remember, it's just this, right? You agree, guys? Cosine of minus alpha is the same as cosine of alpha. Cosine does not care about the sine of the angle. So convert this to this. But now what is cosine of pi/3? Well, look at the unit circle, right? In the unit circle, this guy is given. So where is that, Professor? Cosine of pi/3 here. Pi/3 is here. Cosine is the first coordinate, x coordinate 1/2, right? 1/2. So it's 1/2. So 1/2 here from the unit circle, and cosine inverse of 1/2, cosine inverse of the angle whose cosine is 1/2, going back to the unit circle, look for 1/2 here. This has cosine 1/2, right? It's just pi/3, right? Pi/3. It's in the first quadrant. Remember, I'm allowed to look for from 0 to pi. So this is right, pi/3. Pi/3, right? Or in other words, right, if the angle is properly placed, right, this angle is between 0 and pi now, right, after I did this transition, right? So then you can just cancel this to pi/3, right? Very good. Or go through. This one's similar, guys. Let's try to, yeah, but however, this one deals with, yeah. This is gonna be similar to the one I'm gonna do here, okay? I'm gonna do this one and take that as a reference. It's similar to this. What if they ask you for cosine of sine inverse of 3/5? Cosine sine, I cannot cancel, right? So the strategy, I said, let this be theta. Let sine inverse of 3/5 be some angle theta, right? So therefore, you are looking for cosine of theta there, right? Now, if you let sine inverse of 3/5 be theta, then you are saying that sine of theta has to be 3/5, right? Right? So construct a triangle where that is true. Theta here, remember, sine is opposite over hypotenuse, right? So opposite here 3, hypotenuse 5. We don't have the base, but we can find it, right? B squared plus 3 squared equal 5 squared. B squared plus 9 equal 25. Subtracting 9 both sides, B squared equal 16. Taking square roots, B square root of 16 equal 4, right? 4. So B is equal to 4. Then you are looking for cosine of theta. So cosine of theta will be adjacent 4 over hypotenuse 5, right? And that's it. That's all, guys. Yeah, very good. So this is a technique that you can use in case they ask you to do the composition of inverse trigonometric function with some function, right? Yeah, this similar. Let's look at these identities and let's look at the double angle formula, okay? This ones we did before is basically simplification, right? Cotangent of x times tangent of x, what's that equal to? Well, notice that cotangent of x is 1 over tangent of x, right? And if you multiply 1 over tangent of x by tangent of x, these two cancel. This is just 1, right? 1. So believe it or not, this guy is just 175. Or if you write tangent as sine over cosine, this cosine over sine also can be done 1. What about this? This is similar, right? You should rewrite both. Rewrite secant as 1 over cosine, cosecant 1 over sine, do the math, and you would. Oh, but this one, remember, was a little bit tricky. Oh, maybe I should explain this. I think it requires a different strategy. Secant square, secant square of x, secant square of x multiplied by cosecant square of x. What is this equal to? I want you to take a look at the sheet, the unit circle sheet. There you will find no one. This secant square in the sheet, what is that equal to in terms of tangent square? Isn't it 1 plus tangent square, right? And this guy cosecant square 1 plus cotangent square in the sheet of the unit circle, right? Yeah,
I
in
thought it
this
was
sheet.
1 over cosine.
Yeah, but if you do 1 over cosine, 1 over sine, when you multiply, you're not going to get anything there that is posted, right? You follow, Sherry? You will get just 1 over sine, 1 over cosine square, right? But look at this. This is written in terms of secant and cosecant, right? So instead, I'm going to try this other method, okay? Yeah, it's a tricky question. Yeah, I'm using secant square from here. That is equal to 1 plus tangent square. And for cosecant square, the other guy, I'm using this 1 plus cotangent square, okay? Use that from the unit circle sheet, right? And then remember, we multiply out. 1 times 1 is 1. 1 times cotangent square is cotangent square of x. Tangent square of x times 1 tangent square of x. And tangent square multiplied by cotangent square, that's going to be 1, right? That's probably what you had in mind, Sergio, right? This is going to be 1 because they are reciprocals of each other, right? So I end up with this 1 plus cotangent square of x plus tangent square of x. This is 1, right? 1. Why you say that, Professor? Well, because this guy is 1 over tangent square, right? When you multiply tangent square times 1 over tangent square, tangents cancel. This is just 1. But now, looking back, look at this part. What is this part? The 1 plus cotangent square. Going back to the worksheet, this is just secant square, right? Secant square, right? We're going to put this in yellow for you to remember. And what is this part? This guy. Let's put it in green. Tangent square. Yeah, this is actually cosecant square, right? And this will be secant square. Yeah, this is what we're gonna write here next. Yeah, so basically 1 plus cotangent square, cosecant square, right? Cosecant square there. Cosecant square. And this is this guy, and this guy secant square, right? Secant square. That's it. Secant square. And they are added to each other. So look for that. Yeah, go ahead, Christine, Regine.
So basically it changed from multiplication to addition.
Yes,
for
yes.
those two. Okay.
It changed from multiplication to addition because of the properties, right? But it's very tricky.
Yeah.
Because then, Regine, which one do you pick for your answer between the 4?
Would it be D?
Yeah, but doesn't have the squares.
Oh, A.
Hey, very good, very good. Thank you, Regine, because when you are taking the exam, guys, don't go fast. When you have to pick your answer, try to see which one reflects exactly what you have. Look, secant square, cosecant square, cosecant square. The order of the items does not change in sum, right? So it's gotta be A for 76. Very good, very good. Yeah, probably this is the trickiest one because the rest are just applications of trigonometric identities. Here, for example, right, you have sine square of x plus sine square of x times cotangent square of x. They want you to simplify this. Well, this is going to be sine square of x plus sine square of x multiplied by cotangent square of x, but cotangent is cosine of x over sine of x, right? This is a square, so this should be a square, this should be a square. But once you do that, notice this cancels. Sine square of x plus cosine square of x is what you are left with. But who can tell me what sine square of x plus cosine square of x according to the Pythagorean identities?
1.
1, right? Excellent, excellent, Mamadou. This is 1. So final answer here, 1. Yeah, that's it, right? Yeah, this one's similar. Similar. Let's move on. Let's try to find different forms similar. This divide sine into this, similar. Let's try to reach double angle formulas, half angle formulas perhaps, and the sum of the sine and cosine. Yeah, this one similar. Yeah, this one, guys, with the identities, right? Just try to work them out. But sum of angles, for example, this, right? What to do for sum of angles? We said cosine of alpha plus beta is equal to cosine of alpha, cosine of beta, minus sine of alpha, sine of beta, right? We explained that in our sheet of formulas. The formulas for all these guys are there. Where are they, Professor? Here, right here, here. I am using this cosine of x plus y equal cosine of x times cosine of y minus, look, upper sign with upper sign, minus sine of x, sine of y. It's counterintuitive, right? It's not a type, it's counterintuitive. You expect plus, but it's minus. Then just do it, right? Cosine of 60 degrees, cosine of 45 degrees, minus sine of 60 degrees, sine of 45 degrees, right? Cosine of 60 degrees, if you look at the unit circle, you're going to find out that this is a square root of 3 over 2. Cosine of 45 degrees, if you look at the unit circle, you will find out the square root of 2 over 2. Sine of 60 degrees, sine of 60 degrees, this is actually 1/2. Just look at the unit circle, you will see that this guy is 1/2. Cosine of 60 degrees, 1/2. Sine of 60 degrees is square root of 3 over 2, okay? And sine of a square of 45 is square root of 2 over 2. If you do the math here, 1 times square root of 2 is square root of 2 minus square root of 3 times square root of 2 is square root of 6 over common denominator 4, right? 4. So that's what it is. So this one for 85, then I have as my answer this one. Great. This one's similar. This one's similar in degrees, in radians. What about this one? This type of question. Remember, we explained that these ones are a little bit long. Some of them I'm going to pick just a representative. For example, and I will show you that you should let really the calculator to do the heavy work, right? Look, let's take this number 1, right? Suppose they give you tangent of alpha, and they say that alpha is between pi and 3 pi over 2, meaning the third quadrant, right? This is in quadrant 3, right? And then they say that beta is between pi over 2 and pi, it's in quadrant 2, right? And they ask you to figure out what is sine of alpha plus beta. Well, remember, because of our formulas, this will be sine of alpha cosine of beta plus cosine of alpha sine of beta, right? And I explained to you guys, check what you are given, what you have. I have cosine of beta, right? This guy I have. I don't have this guy. I don't have this guy. I don't have this guy. We'll have to find them, right? But not a problem because they're telling you where alpha is. Alpha is between pi and 3 pi over 2. Alpha is somewhere here, right? On that third quadrant. Put it there and work with the reference angle of alpha. They're saying tangent of alpha is 21 over 20. Tangent is opposite over adjacent, right? According to Socato and stuff. So this is opposite 21, adjacent 20. Find what is this guy, right? C, call it C. And that's going to be equal to the square root of, I'm going to do it with a calculator, right? a square root of here 21 squared plus 20 squared, right? This is what it is. 20 squared, put it within parentheses. Yeah. What is that? It's going to be this guy, 29, right? You found it here, 29. So once you have this, then it means that you can find out any trigonometric function of alpha using this reference angle. What do you mean, Professor? For example, sine of alpha will be what? 21 over 29, right? That we just found. Now, on the first quadrant, according to all students take calculus, this sign should be negative, right? So negative sign is negative. Cosine of beta, we will find out, right? Cosine of alpha now, adjacent 20 over hypotenuse 29. But according to all students take calculus, only tangent and cotangent are positive here. Cosine should be negative, right? Sine of beta, we will find out what it is. Cosine of beta we have is given minus 24 over 25. Yeah, 21. Yeah, great, right? Yeah, so now we need to find sine of beta, right? For beta, beta is in quadrant 2. So put beta somewhere there, beta. And again, work with the reference angle, beta prime. Construct your triangle here. They are saying that cosine of beta is opposite or adjacent. In this case, cosine is adjacent over hypotenuse, right? Hypotenuse. So hypotenuse should be 25, adjacent should be 24. Find this guy with the calculator, square root of 25 square plus 24 square, right? Find that out. So in the calculator, you do this. Notice this is the hypotenuse, right? So we gotta be careful there. If this is the hypotenuse, this should be minus, right? Yeah. When you do the theorem of Pythagoras, this minus, right? Yeah, but what is that? 25 squared minus 24 squared to find this guy. Well, let's see it. The square root of 25 squared minus 24 squared. This gives me 7, right? 7 when you take the square root. So this is 7. So this guy is 7 equal to 7, right? 7. So therefore, sine of beta should be opposite 7 over hypotenuse 25. According to all students take calculus, on the second quadrant sine is positive, right? So this is it. This is all you have to compute. So compute that. Use the calculator, guys, for that, right? Manually will be very difficult. So do minus and minus will be plus, so I don't worry about the sign. So 21 over 29 multiply by 24 over 25, right? Plus negative here, negative 20 over 29, multiply by times here, times 7 over 25. Very good, guys. So now notice this is giving you this decimal version, but you gotta look for the fractional version by clicking on the circle, right? 364 divided by 725, which I see is posted at C. You follow, guys? Yeah. Okay. So use your calculator, your scientific calculator, and that should give you the answer. For 91, then I see we have C. Very good, excellent. Yeah, 364, this whole thing, using the calculator, 364 over 725, right? Excellent. This guy. Yeah, follow this for the others, right? Use your calculator to compute the hypotenuse or the height, the base, whatever is missing, right? Using the theorem of Pythagoras. Right, this is similar. Now let's talk about the half angle formula, double angle formula, right? That is similar. Tangent, sine of, yeah, For this guy, let's say if they ask you for tangent of x minus pi, right? Use this formula, right? Tangent of x minus tangent of pi over 1 minus tangent of x, tangent of pi, right? But tangent of pi is 0. Use your calculator, you will see it, right? Or from the fact that the sine of pi over cosine of pi, sine of pi is 0. This disappears. So this is just tangent of x. So believe it or not, tangent of x minus pi is just tangent of x. This is 94. Yeah, very good. This is similar. Use the formula for simplify. This one, I want to reach this double angle formula. They want you to compute sine of 2 theta, knowing that cosine of theta is this, right? So first you write out the formula for sine of 2 theta is 2 sine of theta cosine of theta, right? Guys, remember this formula? If you don't remember, that formula is here in the unit circle sheet right here. Double angle formula, sine of 2x is equal to 2 sine of x multiplied by cosine of x. This is the formula I'm using there. All right, so let's do this then. Cosine of theta, I have it, is given. I have to find sine, right? They say that theta is in quadrant 2, right? So somewhere here theta is. And use the theta prime, the reference angle, right? Construct a triangle where this information is true. Cosine, which is adjacent over hypotenuse, right? Make the hypotenuse 5. Sorry, the adjacent 5 and the hypotenuse 13, right? Adjacent 5, hypotenuse 13. Adjacent 5, hypotenuse 13, right? Find this guy. This guy B is going to be equal to the square root of 13 squared minus 5 squared. But what is this? If you put it in your calculator, what is the square root of 13 squared plus 5 squared? You're going to see that that's going to come down to 12. For you to see it, this is this. 12, right? 12. So B is 12. So B is 12. So right away substitute here 12, and then you can find cosine and sine there, right? What would be sine of theta? Opposite 12 over adjacent hypotenuse 13. We are on the second quadrant. According to all students take calculus, sine is positive, so this is positive. Let's write a plus sign there. Multiply by cosine of theta. By cosine of theta is given, is minus 5 over 13, right? Now, advice, guys, use the calculator to compute this because they want exact form. Twice, positive 12 over 13 multiplied by negative 5 over 13. Result, our decimal calculator shows first the decimal result, but don't go for that. Click here, look for the fractional result, right? The result as a fraction. It's minus 120 over 169, okay? You see it again? You will get by default this result in decimal, but click here, convert it to fraction, and then this is the one, right? See it? A. So this guy is this minus 5 over minus, sorry, 120 over, yeah, minus 120 over 169. Great. All right, this is when you deal with double angle formula. This is similar, double angle formula. Let's look for one that kind of goes in reverse, that uses the half angle formula. For example, let's pick this one, which is kind of interesting. Cosine of 2 theta. Yeah, this is double angle formula, so we should be okay with this then. This. find cosine of theta. Oh, yeah, but they want cosine of theta, right? Yeah, cosine of 2 theta is this. They want cosine of theta. Yeah, remember for cosine of 2 theta, we have 3 formulas. First formula is this, cosine square of theta minus sine square of theta. Second formula, it's all on our sheet, the unit circle sheet, is 1 minus twice sine square of theta. Third formula, cosine of 2 theta is equal to twice cosine square of theta minus 1. I'm going to use this version here because I'm after cosine of theta, right? I want to find out what cosine of theta is. So I will replace this guy by 2 cosine square of theta minus 1. You follow, guys? Because I'm looking for cosine theta. And then solve for cosine of theta. Adding 1 to both sides of this equation, you will get 2 cosine square of theta equal 1 plus this 1 plus 5 sevenths, right? What is 1 plus 5 over 7? Well, write 1 as 1 over 1, multiply by 7 LCD by 7. 7 plus 5 is just 12 over 7, right? Now, divide by 2 both sides of the equation. Dividing this by 2. Divide this by 2. Here this cancels. Here you get cosine square of theta equal. When you divide by 2, remember you flip this guy and you multiply by 1/2. So multiplying this by 1/2.
How did you get 12 over 7?
12 over 7. Adding 1 to both sides, Sergio, there. I can do this again. I can backtrack. Yeah, remember we added 1. I can put it here better. We added 1 here. This cancels, right? 2 cosine. But also we added 1 to the right side of the equation. So 5 over 7 plus 1 is this. Look, 5 over 7. Yeah, I did, right? 1 plus 5 over 7. You see it now? 1 plus 5 over 7. The sum of these two on the right side is this guy. If you have trouble, guys, dealing with fractions, you can use this. Look, what is 1 plus 5 over 7? I can give you this. Is this, right? But Sergio, look, in fraction 12 over 7. You can see it here, right? 1 plus 5 over 7, 12 over 7. You follow this now, Sergio? This sum, 12 over 7, right? This is what I wrote here. This is this. Maybe I can highlight here. The sum of these two, 5 over 7 plus the number 1 is this guy, right? All right, but then dividing by 2, this is this. So it will be 6 over 7, right? 6 over 7, simplifying. 6 over 7 with 2 into 12, 6 over 7, right? Multiplying these two guys. You can do it with a calculator too. But now you got to take the square root. Cosine of theta, the square root of 6 over 7. The square root of 6 over the square root of 7. But now you got to rationalize this, right? Remember, mathematicians like this rationalize. So multiply by the square root of 7 both. This is the square root of 42 on the top. This is a square root of 7 times the square root of 7, a square root of 49, but the square root of 49 is just 7. Now, this angle theta is on the first quadrant, so it's positive. The square root is positive, so this is it, right? So we're talking about this guy for 100. Yeah, you follow, guys, there? Yeah, very good, very good. Yeah. Now, probably we should finish with something with the half angle formula. I saw this one. This one is interesting. For example, they say find cosine of theta given that sine of theta half is equal to 2/5 sine of theta half, right? But what is sine of theta half? Recall from your formulas in the sheet of the unit circle, you will find this formula. Sine of theta half is plus minus the square root of 1 minus cosine of theta over 2, right? Over 2. You say, where is that, Professor? Where is that formula? It's here. Sine of theta half, sine of x half, plus minus the square root of 1 minus cosine of x over 2, right? I'm using this formula. So you have it there. All right. But now when you replace this guy with this guy, what you're gonna get is the following: plus and minus a square root of 1 minus cosine of theta over 2, right? This is what this guy is, equal 2/5, right? 2/5. I want to get rid of this plus minus business. Remember what we did in class? We decided to square both sides, right? Square both sides. A squaring will take care of the radical part, but also the plus minus will go away, right? What is going to be left is just the inside of the radical, right? This guy, 1 minus cosine of theta over 2, right? Over 2 will be equal to, yeah, maybe we should do this nicely so you can remember that all I'm doing is removing the square. The rest, this part is this, right? All right, now 2 squared is 4, 5 squared 25, right? 25 here. Now I have to solve this equation. One way to solve it is cross multiplication, right? Cross multiply this, cross multiply this. 4 times 2 is 8. 25 times this is 25 minus 25 cosine of theta, right? This is 8. This. Now subtract 25 on both sides. You're going to get minus 25 cosine of theta equal to a minus 25. What is a minus 25? Let's find out. A minus 25, negative 17, negative 17. We're close to the end here, right? Because now all I have to do is divide both sides of the equation by negative 25. And finally, I will get the cosine of theta, eliminating the negative sign, 17 over 25. 17 over 25, which is this B, right? Let's double check. This is fine. Yeah, B. Yeah, this in case you have this stuff related to the half angle formula.